Good morning Queensland, also a special welcome to our interstate and overseas visitors. My name is Christopher Whitehurst. I will be presenting this special presentation on You Be the Judge for the 10th of December 2017. First, I would like to thank Dave and Sarah Taylor from Brisbane Weather. I would also like to thank Des from QSCHW and the many eyewitnesses for coming forward for this presentation. There is speculation on what occurred last night, the 9th of December 2017. Some say a microburst occurred while others say it was the work of a tornado. So let's take a closer look on what is a microburst and what is a tornado. We also look at some photographs of what occurred on the trail of destruction left behind. We also will look at some eyewitness reports as they are stated. So what is a microburst? A weather phenomenon, called a microburst, may cause destruction just as devastating as a tornado does. A microburst is a small downdraft that is the opposite of a tornado and are found inside rather strong thunderstorms. The difference between a microburst and a tornado are that tornadoes pull the air in, and microbursts push air out, and tornadoes usually have the appearance of swirling wind. There are two types of microbursts. The first is a dry microburst, and the second is in the form of a wet microburst. There are also three stages of a microburst. The first stage is the downburst, the second stage is the outburst, and the third and final stage is the cushion. They can be incredibly dangerous, especially to aircraft, due to the wind shear caused by their gust fronts. They are very hard to predict. They can have such high winds like 270 km per hour to 170 miles per hour, that can easily flatten fully grown trees in mere seconds. Dry microbursts. When it rains under the cloud base and or mixes with dry air, it begins to evaporate, which then makes the air cool, and causes it to descend and accelerate towards the ground, which when it does it spreads out in all directions, which is the signature of a dry microburst. Wet microbursts. A wet microburst usually comes with significant rain at the surface which is warmer than the surrounding environment, melting the ice, usually hail, which plays a major part in microburst formation. Now that we know what a microburst is, let's now look at what may cause a tornado. The strongest and most violent tornadoes spawn from large thunderstorms that are characterized by rotating updrafts, called supercells. These supercell thunderstorms form most frequently in the mid-latitude regions of the world, about 30 to 60 degrees north and south, during spring and summer, when the right atmospheric ingredients come together. Three key atmospheric ingredients are an unstable atmosphere, strong vertical wind shear, a change in wind speed, and/or direction with height, and low-level moisture. The tornadoes that struck Queensland's southeast coast over the Australia Day long weekend in 2013 were associated with ex-tropical cyclone Oswald. These types of tornadoes have been well documented in the United States. However, they are probably underreported in Australia due to our relatively low population density in the regions where tropical cyclones make landfall, particularly over Western Australia. They require the same three basic atmospheric ingredients, although the relative amounts differ somewhat from tornadoes that form in the mid-latitudes, including in the famous Tornado Alley. In what may be the first well-documented case in Australia, in February 2011 a tornado associated with Tropical Cyclone Carlos moved through the town of Karratha, Western Australia, leaving behind an extensive damage path. Definition: tornado, mini-cyclone or mini-tornado? There is no doubt some confusion in the public's mind as to what a tornado is exactly, and I think this is largely due to the Australian media's mixed terminology. Do a quick Google search on the most recent event in Queensland, and you will find a number of different words to describe the same phenomenon, including mini-cyclone and the most often used term mini-tornado. According to the American Meteorological Society, a tornado is a violently rotating column of air, in contact with the surface, pendant from a cumuliform cloud, and often, but not always, visible as a funnel cloud. The definition makes no distinction on size. In fact, tornadoes with relatively small diameters have been observed to cause more damage than much larger tornadoes. The Australian media should adopt the word tornado and discontinue other commonly used terms that could be potentially misleading. Australia reports a number of tornadoes each year, although it is not fully understood where most of the tornadoes do occur. Most reported tornadoes seem to be consistent with populated areas as to be expected. Tornado occurrences are normally categorized into two main categories: the warm season or cool season tornadoes. By warm season, it means namely during the spring, summer and autumn months. Cool season occurs during the winter period mainly in the southern states and in particular southwestern Australia, while warm season tornadoes can occur anywhere across Australia. Most of the reports seem to be recorded across the eastern states, particularly Victoria, New South Wales and Queensland. Although this is consistent with population densities, warm season tornadoes tend to vary based on the dynamics and the conditions in which they develop. The main type of tornadoes are those produced from supercells, water spouts that make landfall or landspout tornadoes. The most intense of these are the mesocyclonic type of tornadoes. This type of tornado occurs when the updraft rotation extends to the ground. Conditions that are more conducive for tornadoes to occur from supercells are those that provide consistent boundaries that supercells can ride along for a period of time. Other conditions are generally lower bases of usually less than a kilometer from the ground to cloud base. Research studies support most tornadoes occur in such conditions. Landspout tornadoes can occur in most regions but tend to favor steep lapse rates, and therefore more likely across the inland regions. Boundaries are also important in enhancing the development of landspout tornadoes. Although landspouts can occur along the flaking line of a supercell, they can develop from any type of storms and even under large cumulus clouds. Many of these tornado outbreaks also have the existence of some sort of EML, elevated mix layer, along with a dry line or trough within an enclosed system. Cool season tornadoes are dynamically quite different and tend to favor high wind shear and low cape environments but steep lapse rates aloft. Large polar cyclonic systems can be ideal environments for the development of cool season tornadoes. It is not uncommon for multiple tornadoes to occur in one system. Well, now that we know what and how a microburst occurs and how tornadoes form, let's now talk about last night's storm event which occurred on the 9th of December 2017. Please keep in mind that of which we discussed earlier, the difference between a microburst and a tornado are that tornadoes pull the air in, and microbursts push air out, and tornadoes usually have the appearance of swirling winds. It was a very warm day in southeast Queensland, with a temperature of 31.2 degrees, and the heat index was 34.2 degrees. Thunderstorms started to develop at Moree in the Northern Rivers Forecast District in New South Wales and quickly became severe. Grafton received hailstones the size of tennis balls. These severe thunderstorm cells then made a beeline for the border and crossed into Queensland. The supercells, which were also dubbed very dangerous thunderstorms, also dumped a lot of hail in the Gold Coast hinterland area. The first line of severe thunderstorms went to tornado status set up for at least 2 hours, as it went from the cell heading to Tweed Heads to Bow Desert. Then the supercell lost its strength. It was very dangerous for a while. However, this supercell was not done with yet. The cell then redeveloped and re-intensified in the Sunshine Coast area. There were reports of power lines down north of Estemonto area, also in the Caboolture, Beerwah and Landsborough areas. Here is an eyewitness account. I was outside taking photos in safety as I love taking lightning photos when the rain changed direction, and the wind began to roar like a freight train. I could not see any funnel due to the fact it would have been rain-wrapped as the rain was absolutely pelting down. This is when I realized it must be some type of tornado. I quickly and safely retreated inside to safety. But in this situation where a tornado is likely involved, underground is the only safe place. I live in Beerwah in the Glasshouse Mountains area, and this beast targeted my hometown. Another eyewitness from last night's storm event has reported, along with many others. I'm saying it was a mini tornado because it was swirling as it passed here. You could see it swirling. This can be confirmed by Doppler wind radar from Brisbane, that there were many areas that were indicating a tornado setup. This is where you have blue on the outside, white center and yellow in the center of the white. This means you have wind going in 2 directions in the same area at the same time. On the evening of the 9th of December 2017 there were at least 6 of these happening. There was also reports the Backroad around Nanago north of Blackbutt, that some houses have had trees or limbs of trees through their plate glass windows. Australia Zoo was also damaged and will remain closed until the damage is repaired. The caravan park at Landsborough was also damaged. The kiosk was destroyed and a caravan was also destroyed when a tree flattened it. Luckily the family was not home at the time. The rail service from Caboolture to Gympie North has also been impacted, as overhead lines and rail damaged due to the severe weather event. Energex reported there are near 14,000 people at 10:20 p.m. without power in the Sunshine Coast area. Most is damaged due to severe weather or power lines are down. Dave and Sarah from Brisbane Weather went out to investigate the debris field on the 10th of December 2017. The debris field was in a curved pattern to the northwest. Dave and Des spoke about this, and believe this was a tornado, as it would leave at a debris field to the northwest where a microburst would be more widespread over a greater area, and more of a straight line and not have a turning appearance. Straight line wind is a term used to define any thunderstorm wind that is not associated with rotation, and is used mainly to differentiate from tornadic winds. Downburst winds may begin as a microburst and spread out over a wider area, sometimes producing damage similar to a strong tornado. As we know what the difference is between a microburst and a tornado, I will now leave you to decide on whether you think it was a tornado or a microburst. That now brings us to a close. On You Be the Judge. We hope you enjoyed this presentation, and we thank you for watching. This is Christopher Whitehurst, for Brisbane Weather and QSCHW.